We're now going to use a midpoint Riemann sum to estimate the integral of g of x from 0 to 30. Okay, now that 0 to 30 piece is important because it's going to tell us what the width of our subintervals should be. It's a midpoint Riemann sum, which means it's a little bit different from what we've done in the past. This is what we're asked to find, the integral of g of x dx from 0 to 30. So we start at 0 and we're going to go all the way to 30. But with a midpoint Riemann sum, our intervals skip the number in the middle. Okay, so we go from 0 to 10, and then we go from 10 to 20, and then we go from 20 to 30. Now if you just check, from 0 to 10 is 10, from 10 to 20 is 10, and from 20 to 30 is 10. So that takes us from 0 to 30 in 3 equal steps. Okay? So once you've figured that out, it's pretty straightforward. So our intervals will be the first column. Okay, and the 3 intervals, we've already set them up from 0 to 10, from 10 to 20, and from 20 to 30. Okay, the other columns are as they were for the other Riemann sums. We're going to have width. We're going to have C, and this time it's a midpoint Riemann sum, so put CMP there. Then f of C, and then finally the width times f of C. Okay, so all of these are width 10. Okay, so all of these are width 10. And for Riemann sums, for midpoint Riemann sums, that's typically the case. Usually midpoint Riemann sums, you're going to take rectangles that have the same interval, that have the same width. Not necessarily the case for left-hand or right-hand Riemann sums, but for midpoint Riemann sums, that's almost always the case. So what we do now is we look at the first interval and go from 0 to 10. And this column is always the most important column. So this time we're talking about the midpoint. So it's the midpoint of an interval. What midpoint means is the midpoint of an interval. So the first interval from 0 to 10. Well, the midpoint of an interval from 0 to 10 means halfway between 0 and 10 is 5. So that's what we're talking about. Halfway along the first interval. Then halfway along the second interval, halfway between 10 and 20, is 15. And halfway between 20 and 30 is 25. Now, those are very simple. Those are very simple. But if you're not sure how to do it, what you do is you add. So let's say we take this one. What should it be there? Well, what you do is you would add the two numbers on either side of the interval. So you would add the 10 and the 20. 10 plus 20, and you divide by 2. Okay, 10 and 20 is 30 divided by 2 is 15. And that gives you the number that goes into the C column. Okay? That gives you the number that goes into the C column. So you add the two numbers, the two endpoints of the intervals, and divide by 2. That'll give you C. Okay, so now we know what C's are. Now we know what the values of C are, and we get f of C. So we're going to look up 5, 15, and 25 in the table. So we're going to look up 5, 15, and 25. You look up the C's in the table. So when C is 5, or when x is 5, g of x is 11. When C is 15, or x is 15, g of x is 12. And when x is 25, g of x is 18. Now, again, we do width times f of C. That's the same for right hand, left hand, and midpoint. So the width is 10 times 11 is 110. Then we have 10 times 12, which is 120, obviously. And finally 10 times 18, which is 180. We add those up, and we get, is it 410, I think? Yeah, 410. And therefore, that's our answer. Integral from 0 to 30 of g of x, and I think I went with f's. I'll go back and change that now. I'm sorry for any confusion. So used to doing everything in terms of f is approximately equal to 410. That's our answer. And let me just go back and change this for you. so that if you've been wondering about it, I can try and hopefully ease that confusion now. These should be G's instead of F's. Okay, alright, so that's the last video there, and hopefully it makes sense to you.